subscribe to our channel for latest video series on GATE, UGC, NET and more. Also press the bell icon so that you never miss an update on any latest video. For more information, you can visit our website or call on the numbers below. People, so today we look at a topic from quantitative aptitude. This is a new topic that we are covering today, which is percentages. Now, why we are using percentages? What does this mean? What are the different models that are being asked in examination? Everything we are going to look one by one, right? So, firstly, we understand what does a percentage means. See, this percent, this cent represents 100. Okay, this is what we calling 100 in French. Cent is 100, right? So, percent means per 100. That is, for every quantity, each quantity, we are taking reference as 100. Okay, we are trying to scale down everything with reference to 100. Fine. Why are we doing this now? See, in order to make comparisons, in order to compare growth rates, economic deficits, everything, marks, quantities, what we need is, see, they are going to have their different references, fine. Everything is going to be having their own reference. Now, if you want to make comparison of two quantities, they should have common reference point. Only then you can compare two things, right? You cannot compare 5 bananas to 2 motorcycles, fine. They need to have a common reference. In having that viewpoint only, we are having this concept of percentages. See, I will give you an example. Suppose there are two students, A and B. Now, the student A scored 200 marks out of 500. The student B scored 70 marks out of 100. Now, if I compare their marks directly, okay, A clearly scored way much marks than B, right? It has more marks than B. But this is not a valid comparison. Why? Because their total marks are different, right? They are having total benchmarks. So, it is not valid to compare their marks directly. Now, what do I need? I need a common reference point. That common reference point is basically commonly taken as 100. What do? I scale down the total marks for this examination to 100 and then compare that if this examination were of 100 marks, how many marks would has this candidate got, and then I can compare it with B, right? This is how we use the concept of percentages to make comparisons, different comparisons of growths of country, economic growths, financial growths, find marks of students maybe, right, percentage growth of a country, city, school, whatever, right. So, that is why using this concept of percentages. Now, see, if you try to find percentage, how do you find a percentage? If you are given a fraction, you multiply that fraction with 100, right. What happens is this fraction, see, we've learned about fractions, okay. Fraction is basically with reference to 1, okay. Every fraction is with reference to 1. 1 means whole or complete. Fraction refers to part of whole, part of 1, how much part of 1. Now, if you want to scale it up to 100, what you need to do is you need to multiply it with 100. So, what do? If I need to find percentage of A, this is going to be percentage of A, then what do I need to do? I need to multiply this fraction with 100. So, 200 by 500 into 100, which is going to make it 40%. Okay, so this student scored 40% marks. Similarly, if you look for this B, see, already its total marks were 100, so you do not need, but we are following the same procedure. What do you need to do? You need to multiply this fraction with 100. So, you see that this student obtained 70% marks. Now, it is valid to make a comparison between these students' performance, right. This student scored 70% marks, whereas this student had scored only 40% marks. Now, if you look, you can clearly see that B performed much better than A. Comparing marks could not give us this idea because points of reference were different. To bring them to a common level, to a common point of reference, we are using this concept of percentages, right. So, you have seen how to find percentage. If you are given a fraction, you multiply it with 100 and put this percentage sign. This is how you are finding percentages. Let us look at an example. Convert 3 by 5 into percentage. Now see, what we are basically doing is, it's 3 by 5 is, what does this 3 by 5 represent? That if you break anything, if you just divide one whole, one part into 5 parts, then 3 parts of them are represented by this fraction 3 by 5. Now we are asking that if 100 is divided into 5 parts, what are its 3 parts going to be, right? That is what we are doing. So what do? I just multiply this 3 by 5 with 100 and put a percentage sign, right? So this is going to be 60%. This is how you are converting fractions into percentage. Fine. And how do you convert a percentage back to fraction? Suppose I ask, convert 60% into fraction. So what do? Just reverse of this procedure. You remove this percentage sign and divide the number by 100. Fine. So this is going to be 60 by 100 or 3 by 5. Right, you have got back the same fraction. So this is how you find percentage of a fraction or convert percentage back into fraction. Okay. So basically what we are trying to do is, we are going to look at some models that have been asked frequently in examinations with the help of questions, right. Before we start, we take up a very simple question. Suppose you are given that there is a certain number, okay, of which, suppose I say 20% of a certain number is 5. Then what is the number? What is the number? Fine. So I am saying that there is a number of which 20%, if you find 20% or 20 by 100 parts of that number, it is going to be 5. Then what is the number? See, if you just convert this into fraction, firstly what I do is I convert it into fraction. How do you convert it into fraction? You remove this percentage sign and divide by 100. So what am I saying? 20 by 100 of a number, suppose that number is x, I am supposing. So what am I saying? 20 by 100 of x is 5, right? You can just replace this off with multiplication, fine, because this much part of x was 5. So now if you just solve it, you can see that x is going to be 25. So the number was 25, fine. So this is what percentage means, okay. Then see, don't confuse with 100. 20% simply means 20 by 100 in terms of fraction, okay. 20 by 100 parts, 20 by 100 means 1/5. 1/5 of a number was 5, so you could easily find the number, it is going to be 25. So we are going to cover all the models that I asked one by one with the help of examples. So look at the first question. What they are saying is, if A's income is 30% less than that of B's income, then how much percent is B's income more than that of A's? See, first thing that you need to learn is, answer is not going to be 30, fine. Why? Because we are talking in terms of percentages, we are not talking in absolute terms. If I had said that A's income is rupees 30 less than B, then how much more is B than A? Answer would have been 30 rupees, which is absolutely right. Right now we are talking in terms of percentages. So first point is, answer is not going to be 30. Now what it is going to be and how do you approach these kind of questions? See, there are a lot of shortcuts, there are a formula that you can remember, but there is one very simple trick that I would recommend you to follow. I am also going to tell you the formula and shortcuts anyway, but one simple trick that I would advise you to follow is, whenever you are working with percentages and you do not need to find any absolute value. See, they are not asking you to calculate income of A or B, right? So what do? When they are giving you percentages, they are asking you answer also in percentages. Just assume some values to be 100, whatever value you are comfortable with, you assume to be 100. Why? See, when we are working with percentages, we are taking reference as 100. If you assume some values as 100, it is going to ease up some calculations for you. I will just explain how it does this in this question, right? And okay, and one more thing. Reference is going to change, okay. Whenever they ask how much income more than that of A income, all this, then the denominator is going to change. Let us start with a small example. We are going to come to this question later. Suppose I say there are two people, Suresh, okay, and this is Ramesh. Fine. Now both of them have separate incomes. Suppose Suresh earns 500 per day and this Ramesh earns 700 per day, okay. These are their respective incomes. Fine, so Suresh is earning 500 rupees per day and this Ramesh is earning 700 rupees per day. Now if I ask you, so okay, firstly I ask you who is earning more. So clearly Ramesh earns more in one day, fine. So what do I say? I ask you how much more is Ramesh earning than Suresh. Okay, listen to the question carefully. How much more does Ramesh earn? See, I have not talked about percentage, so you just answer me in absolute terms. How much more is he earning? He is earning rupees 200 more earned than Suresh, right? Than Suresh. So he is earning 200 rupees more, fine. Now if I ask you how much percent more, okay, if I just modify this question and ask how much percent is Ramesh's income more than that of Suresh. Now see, we know that what is the concept of percentage. Why are we finding percentage? To scale it down to a reference of 100, to a scale of 100, to compare it, right? Now in absolute sense you know that this person is earning rupees 200 more, fine, but you need to have a scale. On scale of what? Fine, you cannot directly multiply it with 100 to find percentages. Now see, I have asked with reference to Suresh, right? More than that of Suresh. Now my reference here is Suresh. So what do I do when I need to find this percentage? I am going to divide this 200 by income of Suresh, okay. 200 by 500. Now I needed to find percentage, so multiplication with 100. Find whatever you get 40%. So this person earns 40% more than Suresh. 40% of whose income? Suresh's income. If you just find out, you will see that it's going to be 200 only, right? So reference is very important. If you change this denominator, your answer is going to change, okay. So read very carefully. They ask that how much percent is Ramesh's income more than that of Suresh. So reference is going to be this person's income you have to divide, fine. So this is how you have to approach these questions. Now see, so this was just an example so that you know that what is going to be the denominator. Everybody was sure of the numerator, how much it is more, 200, that we can clearly see, but this denominator you decide carefully because you have to see that who is the reference, fine. Now we come back to our question. So what I was saying is, whenever you have questions of this kind where you do not need to find any absolute value, what do? You just assume salary, income, whatever they are saying, of one person to be 100. Fine, you read this question once and then we decide what do we assume. So they are saying A's income is 30% less than that of B, okay, and how much percent is B's income more than that of A, okay. See, you have two options. What are the two options? First option is, if you assume that A's income is 100, right, then what is going to be this salary of B? See, this A's income is 30% less than B. See, why we are assuming 100 is because 30% of 100 is simply going to be 30, 50% of 100 is 50. So it makes it easier to work with percentages if one base value is 100, right? Then it is simple addition, subtraction. See, some of you would say, I do not like a person earning so less. So what would you say? You would say that at least let him earn 200 per day. See, I have no problem with A earning 200 rupees, but what is the problem is, this has to be 30% less than some number. Now you need to find out that number which is going to be 30% more than this number. It includes lot of calculations. You need to find out what is 130% of 200 going to be, okay, I guess 260 maybe. So whatever, it is going to take up a lot of your brain and time, okay. So what do? I just assume it to be 100. Now what is the question says, this income is 30% less than that of B, then what should have been the income of B? It must have been 130. So this is one way that you can proceed, okay. We'll see both the ways, okay, fine. Other way would be, what can the other possibility be? I assume that income of B was 100 rupees. If income of B was 100 rupees, what would have been A's income? 30% less than that of B. See, okay. One more thing that I would conclude here. I'll just tell you why this method is going to be wrong, okay. Thinking like this is wrong. Why? So now what do they say? The A's income is 30% less than that of, see, this is very important here, 30% less than that of B's income. Now 30% of 100 is going to be 30 less, so this is going to be 70, fine. Now see, why is this wrong and that right? Okay, how do you judge which one of them, which one of the cases you should assume? Okay, there is only one right case here, which is this one. This is going to be wrong. Why? Because if you read the first line carefully, they say that A's income is 30% less than that of B's income. 30% of this you have to find and you subtract. If you do that, 30% of this number is going to be 39. If you subtract that, income of A is going to be 91. So there is no point assuming it. If in any matter how whatever, you need to take this, you cannot take income of A to be 100, it should be 91. That is what I was talking about, okay. That is what I am talking. Reference is very important. Clearly it says 30% less than that of B's income. Reference is B's income, okay. 30% of B's income you should find and subtract. Fine, see these numbers, mostly people will not be interested to work with these kind of numbers. So it's better you assume like this. They have given that it is with reference to B's income in the first line, so you assume that income of B was 100, accordingly income of A is going to be 70, fine. So now we clear that A earns 70 rupees and B is earning 100 rupees. Now you read the next line of the question. So they are asking that how much percent is B's income more than that of A's income. See, if I ask you in absolute terms again, then how much is it more? 30 rupees. They are having a gap of 30 rupees. So it is 30 rupees more, but with reference to what? More than that of A's income. See again, reference is A's income. So if you need to find percentage, what do? You divide this 30 by 70 and into 100. Fine, you just multiply this, whatever you are getting, 300 by 7. So this is going to be something, I guess 42 point something, 42.8% or whatever, fine. So they also have a shortcut for this. If some of you might have a good memory, so you can just remember. I am going to write it as a note here. For others who cannot remember things very easily, you just follow this kind of procedure. Assume one thing to be 100, okay, one value to be 100. So I am writing it as a note. If A is X% more than that of B, then B is less than that of A by, so this pen is not working, X upon 100 plus X into 100%. Fine, this is same thing, okay. If you just look, see, if you just look it quickly, what it is saying is, if A is x% more than that of B means you assume B was 100, then what would A be? A is going to be 100 plus x. Now what they are saying, B is less by 100, x, you can clearly see in absolute sense it is less by x, and that of A means reference is going to be A, so it is going to be x upon 100 plus x into 100. They are giving the formula in same respect, okay, this is same thing, but some people are good at remembering, so you just remember this formula directly, okay. If A is x% more than that of B, then B is going to be less than that of A by this much amount. Similarly, you can see, okay, this is just an extension only. Note 2, if A is x% less than that of B, then B is more than that of A by x by 100 minus x into 100. Fine, does not take up a lot of brain, lot of time also. So some people are really good at remembering, so you can just remember these formula directly and use them in questions. For others, I have told you the shortcut. What do? You just read the first line very carefully, see who is the reference, whoever is the reference, denote them in the value 100 and accordingly you work out the question, okay. Going to take you 20 seconds or less maybe. Fine, so this is one model of the question. Now we look at the next one. So look at this question, look at the next question. So what does this model mean? What do we have to do in this model is, see, they are comparing two different quantities to a third similar quantity, okay. They are going to compare the first quantity with the third quantity, second quantity with the third quantity, and going to ask you the relation between the first two quantities. Now what do you do? First thing that I would like to tell you here is, just look at the question. What percent is A of B? Percent is A of B. A of B means you have to find the value of A with reference to B. See, what is a very important thing in percentages is, what is going to be the numerator, what is going to be the denominator. Once you are clear with the numerator and denominator, it is just multiplication with 100, right. So main thing is what is going to be a reference. Now they are asking that what percent is A of B, which means value of A is going to be the numerator with reference to what? Of B. Of B means value of B is going to be the denominator, and you need to multiply with them 100 and put a percentage sign. So this is what you are going to do basically, okay. Now to find this, we are taking help of a third quantity C, okay. Now what do they say? See, just make it a habit. As soon as you read the question, as soon as you start going through the lines of the question, start making mathematical equations corresponding to the English language lines, okay. So that saves a lot of time, especially in aptitude questions. As soon as you read, okay, see, this is of, all this are actually representing some symbols of mathematics. Is represents equal to, of represents multiplication, right, percent, you know, it represents division by 100. So as soon as you get the question, just make some mathematical equations so that you do not even need to go back to the question. See, this comes with practice maybe, but you should be such fluent in this aptitude is, you do not need to read question more than once. How can that happen? Just try to see, when you have practiced a lot, what is going to happen is you are not going to even see these words, if, and, then. See, all these are useless words. Only this is of, all these are useful words. So you will start reading between the lines once you get into practice. So just try, start now so that you get that practice, get that fluency. Okay, so we start with the first line. A is means equal to 20%, 20% means 20 by 100. Right, this is how we convert into fractions, okay. See, percentages are not operational in mathematics, you cannot operate with percentages. To operate any percentage, you need to convert it into fraction, and how do you do that? By dividing by 100, right. 20% of means into C, right? So this is my first equation, and means end of statement. Come to the next line, B is 25% means 25 by 100 of C into C. This is going to my second equation. Now already when we read this question first time, we saw that we need to find out this. Okay, we need to divide A and B. Fine, so just perform division, just divide 1 by 2. What do I do? 1 divided by 2. So what are you going to obtain? On LHS you are going to obtain A by B. On RHS you are going to obtain 20 by 100 into C upon 25 by 100 into C. C cancels out, 100 cancels out. So you got 4 by 5. Now you got this values, just multiply with 100. So what do you get? 80%. Fine. So this is the simplest trick that you can follow for questions like this. See, since this is the first question that you are seeing, you have done this much also. I'd suggest practice a lot of aptitude, so that you reach a stage, you read this question once and you are writing this directly. Okay, you are going to reach that stage, just do a lot of practice. So see, questions like these are very rare in examination. They are not going to ask you such easy questions, but there are going to be exams where there are going to be a lot of questions of aptitude. In those exams you may get questions like this, so they are just to give you some extra time for tough questions. Don't waste time writing all this. Nobody is going to check your written work. Okay, yeah, in case you make a lot of silly mistakes, you must write, you must follow all these steps, but I'd recommend that you practice well so that you can write this step directly. Fine, so this is one model. If when two quantities are compared with the third quantity and relations being asked between those two quantities, this is how you solve. Okay, so we look at the next model of question now, which is, see, what they are giving in this type of questions is commodity. There is one commodity, its price is going to increase or decrease. Accordingly, they are asking you that how should the consumption of the commodity increase or decrease, so that total expenditure remains same. See, what concept we are using is expenditure on a commodity is going to be, expenditure is actually going to be price of the commodity into consumption of the commodity, right? It is going to be the product of these two. If price of a commodity increases, consumption has to be decreased. If price of the commodity decreases, consumption has to be increased, because we need this expenditure to be a constant. Fine, so we use the same concept. What do we say? P1 into C1 should be equal to P2 into C2. This is the same concept that we use in work and time problems. Okay, we equate man, days and hours, right? So this is the same concept that we are using to keep the expenditure to be constant, to be a same number. If price increases, consumption should decrease. Fine, that means this product must be a constant. Now they are going to give you in percentages. So as we have said, we assume one of the quantity to be 100, so that it is easier for us. Okay, if you look at this particular question, they say that price of sugar increases by 25%. So I assume that initially price of sugar was 100 rupees 100 for 1 kg and consumption was 1 kg. Fine. Now they are saying that this price increased by 25%. 25% increase means new price is going to be 25 rupees more, which is 125. Now they are asking you something about this consumption, new consumption C2, right? How much percent its consumption must be reduced. So let us see. If you just find out C2 from here, you see that it is 4 by 5. Okay. See, if you want to find this directly in terms of percent, what can you do? You assume initial price to be 100, initial consumption also to be 100. Fine. Now this C2 is going to be 4 by 5 into 100. Since initially also it was 100, now whatever value you get, what value am I getting? 80. 80 you are going to get, right? So see, since this was 100, already your base was 100, now the C2 became 80. Now they are asking how much percent it should be reduced. This reduced by 20, base was already 100, so directly answer is going to be 20%. Fine. So this is a very easy trick to follow such questions. We having a formula also, we having a similar kind of formula that we had. Suppose, okay, I am going to give this to you as a note, but I'd recommend you follow this method, because see, you do not need to remember anything if you are doing like this, okay. If you are trying to follow the formula, you need to remember a lot of things. Fine. So what we have done is that this product is going to be constant. Initially we assume both of these values to be 100 because we are working with percentages. Now if this was 100, then this price increased by 25%, which means price became 125. Accordingly consumption became 80. Already it was 100, now it became 80. So this decrease of 20 is going to be the same. This is going to be the answer, 20%. Fine. So there is also a formula with which you can attempt such questions. Let's see. If price of a commodity increases by P percent, then to keep the expenditure as constant, its consumption must be reduced by P upon 100 plus P into 100%. Fine. If you just put the values in this formula also, you are going to get the same answer, okay. If the price of sugar increased by 25%, here value of P was 25. If you just put it in this, 25 by 125 into 100 is also going to be give you the same answer, that is 20% only. So people who can remember very well, who are very good with formulas, you can just remember this formula, and for others I have already told you the shortcut. Fine. So there you can make a change here, increases or decreases, let us say decreases by W%, then to keep expenditure constant, consumption must be reduced or increased. I am writing this in blue, okay. Then this is going to become W by 100 minus W into 100%. Fine. So both. In case the price decreases by W%, then this consumption must increase by this much percent. Okay, same logic it is going to follow, right. So this is one model of question that they are giving. So there is one model or maybe two models more, we are going to look at them also. Right, so look at this question now. So what they have given is, they are giving you the annual increase in some quantity, or here they have given population of a city. So population or annual increase in some quantity is given, okay, percentage increase is given, and then they are going to give you one value, maybe most probably they are going to give you the present value. Then they ask you the value 2 years before, 5 years before, or 5 years forth, after 5 years, okay. So what basically I am saying is, suppose present population for a town is P, right. Now I say that it increases by 10% in 1 year. Then after 1 year, what is going to happen? After 1 year, what happens? After 1 year, this value, this increased by R% in 1 year, right. Then what is the increased population? R% of P, or I can say R by 100 of P. Rp by 100 increased. Initially it was P. So what is, this is the increased population, maybe number of kids that were born in that town in 1 year, okay. Increased population. Now initially population was P. Then what is going to be the total population? Total population, let me say this P dash. Let us assume this is P dash. Then P dash becomes P plus Rp by 100, right. Now what am I saying is, I can take P common, right. So I can say this is P going to be P into 1 plus R by 100. Now this is what happens after 1 year. Suppose I talk about another year. See, the point here is this R% increment is always going to happen on the present population. Now the present population is not P, it is P dash, right. So what happens after 2 years from this instant, we're talking about this instant, okay, this is the present. So after 2 years what happens? Similar to this, after 2 years, let us say population becomes P double dash. Then what is this P double dash going to be? This is going to be P dash plus Rp dash by 100. Or if you just take out P dash common, this is going to be 1 plus R by 100. If I try to write this in terms of P, I can just substitute its value. This is going to become P into 1 plus R by 100 into 1 plus R by 100. If you keep on following this procedure, you will see that this formula, this method can be generalized for n number of years. How? If we talked about 1 year, what happened? We had to multiply once with 1 plus R by 100. If you talk for 2 years, you multiply it with 1 plus R by 100 2 times. So what is going to happen after n years if population keeps on increasing with the same rate of R% per year, per annually, then what is going to be the population of the town after n years? It is going to be P, which is the present population, into 1 plus R by 100 into n. So directly we can just use this method to calculate our answers, right. And if they're asking you, suppose they're asking you what was the population before 2 years. Before 2 years means this present population is being given. So before 2 years, to calculate this, you need to divide with this factor. Okay, let us look at this with this example. So they are saying that this increases by 20% annually, which means value of R is given as 20%, and present population they say is 1,20,000. Okay, so they are asking you that what would the population 2 years forward. See, population is increasing by this rate. If the population was decreasing, you would use a minus sign here, okay, because the population is going to decrease. Since this is increasing, what is going to be the population after 2 years? It is going to be P into 1 plus R by 100 to the power 2, because they are talking about 2 years, fine. Just putting the values, what are you going to obtain? Right, so you can just solve this. Fine, so if you just solve this, you can get the answer. Right. Now if you look at the second part, they are asking what was the population before 2 years. Okay, now if they are asking you the population before 2 years, what you are going to do is, see, population before 2 years would be less than the present population, obviously, because it is increasing per year. So what do you do? Instead of multiplication, we just need to perform the division. Okay, why? See, population 2 years means they are asking you to find this P, and P dash is given. Okay, now this has become the present, this has become the increased population. So to find P, what do? You just divide. Just I don't think we need to do this. So just to find P, what you are going to do? You are going to perform this. Fine. So this is how you can find population before 2 years. Right. So this is how you are performing questions of this kind. Now there is one extension to the same concept. See, what did we assume here is that this population or the increase in this quantity of population, whatever it is same for each year. Okay, it is increasing or decreasing by the same amount every time. Right. Now if I just make a small change to the same concept, if this quantity, if this population does not change by the same amount every year, but changes by different amounts, different percentages each time, what does happen? See, suppose we assume that there is a quantity, let us say A. Okay, now what happens to this A? This A gets increased by X% first. then it gets increased by y%, then it gets decreased by z%. So I ask you, what is going to be the net percent change in value of A? Fine, we just move step by step first, then we can derive a general formula for this form. See, if this A increases by x% in the first instance, right, let me assume that its value becomes A dash. What it is going to be? A plus x% of A. Right, this is what its value going to be. Now this y% increase is going to apply to A dash, not A, right, because it happens after this. This is a series, right, this is series of actions. After this x% increase has been done, now this y% increase takes place. Then A double dash, this is going to be A dash plus y upon 100 into A. Now next again what happens, this is going to be decreased. This is also going to be A dash. So A triple dash is going to be, this is also going to apply to A double dash. So this is going to be A double dash minus Z by 100 into A double dash. Fine. Now if you just put values, what are you going to see? See, I take out this A double dash common. So going to be 1 minus Z by 100. Putting values of A double dash, this is going to be A dash into 1 plus Y by 100. Into 1 minus Z by 100, putting value of A dash, A into 1 plus X by 100 into 1 plus Y by 100 into 1 minus Z by 100. See, if you see the final value of this number, what have we actually done is, see, this is just an extension of the previous concept, okay. In previous concept also we were doing the same thing. The difference was that it was increased by same value each time. It was increased by x% each time. So what did we do? We just put this in powers of this single term. Now it is being changed by different percentages each time. Sometimes it gets increased by x%, then y% decreased by z%. Whatever. So we are getting these different terms, right. So this is how you are going to solve problems like this. Now suppose I ask, what is the percentage change in A? You know what is going to be the percentage change in A. What do you do then is, what do you need to do is, see, this is actually the percentage change in A, right. This is what has changed. So what do? You just find, okay, if I am required to find percentage change in A, then what do you do? What do you need to do? A triple dash minus A, right, upon A into 100. Fine, you just find this value, okay. Final value is going to be this one only, final value is this only, right. So after you find the final value, you can just find what is going to be the percentage change in A. See, reference is A because we are finding what with reference to A, with respect to A, what value has it become, okay. We can take an example on this one also. So look at this example. They are saying that there is a man who earns 1500, who used to earn 1500. Now what happened? He got an increment of 10%, 20% and 30% in 3 consequent years, 3 continuous years, right. So they are asking you to calculate his present income. So we are using the same concept, okay. We need to find the final value of his income. So final income, final value is going to be, this was his base salary, base income that he was getting. Then he got an increment of 10%, so 1 plus 10 by 100, again 20% and then 30%. See, since he got a raise each time, we are using these plus signs. Suppose he did something wrong, suppose he got a depreciation value, market fell down, whatever happened, then we would have used a negative sign, okay. He got a raise every time, that is why using plus signs, fine. So just be little careful about little things. So what do you get? 110 by 100 into 120 by 100, right. So if you just perform this multiplication, what do you get? 2574, right. So this is going to be his present salary. See, they are not going to ask you such complicated calculations in exam. For example, I have taken this question, right. They are not going to ask you such tough calculations. They are going to be very easy, right? So anyway, I hope you got this concept. So if you have different changes in value, this is how you proceed. If you have same annual growth, same change, you just put a power, you just put 3 times it was increased, you just put a power to this, fine. So I think we've covered all the models that have been asked from percentages. In the next video, we'll try to cover more of examples, more of questions, all the complicated questions that we get. In case we left something, you can just leave it in comments if we have left some point from percentages. Also, if you have any doubts, any questions, any queries, you can always leave that in comments. Thank you.